Okay, this is the solutions video for the 1.5 homework on page 84. Number one, looking at this graph, from the left, it approaches infinity. From the right, it approaches positive infinity, so it's positive infinity from both directions. On number two, from the left, negative infinity. From the right, positive infinity. On number three, so from the left, positive infinity. From the right, negative infinity. All right, and then number four, from the right, positive infinity. From, from the left, got that backwards, positive infinity, so going up like this. From the right, negative infinity. All right, so let's see on, so from the right, I think I got that backwards on number four here. So here are the answers. Positive infinity from right on number two. Yep, that's right. And then number three from the left would be positive from the right. And on number four from the right, coming from the right, actually it is positive. I'm sorry about that. And then from the left, it's going to be negative. So, yeah, from the right, let's say we're going right here, we're going, and then we're going up by the time we get to the asymptote. So coming from the right, it's going up. Coming from the left, if you follow it from asymptote to asymptote, it is going down. Once you get to, say, -2 right there, it's going down. So I had that written right. Okay, number five, I mean, it's got a table on there. We could just do it this way. -3 from the left, that's going to be, from the right. Take that limit. So you'd have 1 over, so -3 from the right would be like -2.99. If you square it, it's going to be a little less than 9. So that'd be over a small negative. So that's going to be negative infinity. And then from the left, -3 from the left, say that's like -3.01. You square that, it's going to be a little bigger than 9. So 1 over a small positive. That's positive infinity. Okay. So I believe that's all the question's really asking for, is that. So from the right, negative. From the left, positive. Okay, and then 9 through 43, 9 through 23 are just asking for where is the vertical asymptote. So it's where the denominator is 0, and it can't cancel out. So at number 9, it's where x is 0. Number 11, you can't factor the top. We could factor the bottom potentially, x, and then let's say -2 plus 1 maybe. So that'd be -x in the middle and then -2. So it's the numbers, since you can't cross anything out, the vertical asymptote occurs at x equals -1 and +2. Okay, well, those two x values that make the denominator 0. For number 13, we have x cubed. Can't really do anything with that. We could factor into x plus 1 times x minus 1 on the bottom. So we'd have a vertical asymptote at x equals plus or minus 1. There. All right. Sorry about the confusion on number 4. I had to kind of eyeball that one again. Okay, number 15. So that one, we have f of x is tangent 2x. So that's going to be sine 2x over cosine 2x. So we're worried about where does cosine 2x equal 0? Well, look at the unit circle. Cosine is x, it's when it's pi over 2. So we could say 2x equals pi over 2, right? Because cosine of pi over 2 is 0. So x would be pi over 4. And then it's every pi over 2 units after that. So it would be plus pi over 2 times n, where n is an integer. Okay, so if you're not sure, plug pi over 4 in for x. 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. But the easiest thing is just to let that 2x equal pi over 2, because we know that's where cosine is 0. And then we know every pi over 2 units, the thing repeats. So you can write it out like that. Okay, 17, we have t of t is equal to 1 minus 4 over t squared. Well, don't let the 1 minus out front. This thing becomes undefined. It has a vertical asymptote at t equals 0, right? Because 4 over 0 would be, it'd be a vertical asymptote. There. So don't overcomplicate it. 19, we have f of x is equal to x over x squared plus x minus 2. So probably this thing is going to factor. I'm going to try it anyway and see where any of that is equal to 0. So we'd have x, and plus 2 minus 1. Nothing cancels from the numerator. So that is going to be, we have a vertical asymptote at x equals -2 and 1. All right, 21. We have g of x is equal to x cubed plus 1 over x plus 1. Okay, that is perfect cubes. That will factor with a is equal to x and b is equal to 1. So that will factor into x plus 1 times x squared minus x plus 1. You can look back in your notes and see that formula. You will need that formula to be memorized for the test, over x plus 1. That cancels out, so there is no vertical asymptote. There is a hole at x equals -1, which is removable, but it didn't ask for that. You have the correct answer if you just say no vertical asymptote. Okay, 23, I have s of t is equal to t over sine t. So it is where sine t is equal to 0. That would give us a vertical asymptote. Sine is 0 at 0, so it's going to be 0, and then plus every pi units. The 0 comes around again. So 0 plus pi times n, okay, is where the vertical asymptotes occur. So 0, pi, 2 pi, 3 pi, etc. on forever, and also in the negative direction. All right, that's all I can fit. And if they gave you a domain restriction, you know, then you would just have to write the values in the domain restriction, which might just be 0 and pi or something like that, or 2 pi. All right, 25. We have f of x equals x squared minus 1 over x plus 1. we can factor the top into x plus 1 times x minus 1 over x plus 1. That cancels out, so there is no vertical asymptote. There is a hole at x equals negative 1. Okay, so that's removable. So we have a removable discontinuity at x equals negative 1. 27. F of x equals x squared plus 1 over x plus 1. Well, the top won't factor, so it's where the denominator is equal to 0. So we have a vertical asymptote, since you can't cancel out, at x equals negative 1. Brilliant. All right, 29. We're going to find the limit. As x approaches 2 from the right of x minus 3 over x minus 2. Okay, so what we're looking at here, we're just going to plug that in. That's going to be 2 minus 3, negative 1 over 2 from the right over a small positive. So negative 1 over a small positive would be negative infinity. All right. Now, again, that does not exist. The negative infinity just gives you some information about the graph, all right, the direction that the graph is going. So it does not exist, but this is additional information. All right, 31, the limit as x approaches 4 from the right of x squared over x squared minus 16. Okay, on this one, so we're just taking the limit here and from the right. So the top would be 16. A little greater than 4 squared would be a small what? Small positive. So that's going to be positive infinity. Brilliant. 33. We're going to do the limit as x approaches negative 3 from the left of x squared plus 2x minus 3 over x squared plus x minus 6. Let's see if we can do some canceling here. Okay, we've got x, how about plus 3 minus 1? That'd give you a positive 2 in the middle, negative 3 on the end, and on the bottom, x, and then how about plus 3 minus 2? So we can cross that out as long as x does not equal negative 3, right? So I've got x minus 1 over x minus 2. So we don't have to look at the whole small positive thing and all that here, since it's now you can plug the numbers in. Okay, negative 3 minus 1, that'd be negative 4. Negative 3 minus 2 would be negative 5. So the answer on that one is 4/5. It's only when you have a number over 0 situation that you need to look at the small negative, small positive thing. But we didn't have that anymore once we canceled this out. We do have a hole at x equals negative 3, but it didn't ask you for that. The limit is 4/5. Okay, so I hope that clears that up. If you're not sure when to do the small positive and small negative thing, It's the form non-zero over 0 where you have to start looking at that, which we were able to get rid of that form through cancellation. Okay, so we are on 35. I want to take the limit as x approaches 0 of 1 plus 1 over x. Okay, so that's going to be 1 plus, and is that 0? It looks like it's from the left there. My book is really hard to read. 1 plus 1 over, so from the left would be a small negative, right? Coming from the left. So that's 1 plus negative infinity. And the 1 doesn't matter. That's just going to be negative infinity. All right. That does not exist, but that's some additional information about this limit. 37, we have the limit as x approaches 0 from the right of 2 over sine x. Okay, so again, this is non-zero over 0 form. If we plug in 0, sine of 0 is 0, but from the right, we're in quadrant 1, right? Quadrant 1, 0 from the right, so just a little bit above 0. We know sine is positive in quadrant 1, so that would be 2 over a small positive, or I think in other lectures I've used tiny, right? So 2 over a tiny positive is going to be positive infinity. All right, 39. Okay, taking me a while to get all these done. So 39, we have the limit as x approaches 1. And that is, it doesn't look like it's from the left or right to me from the book. So x squared minus x over x squared plus 1 times x minus 1. Well, what could we do here? We can't factor that, but we could factor an x out of the top. And you're left with x minus 1. And that allows us to cancel out this right here as long as x does not equal 1, right? So I have the limit as x approaches 1 of x over x squared plus 1. Okay, so we're going to plug in now. That's going to be 1 over 1 plus 1, 1 half. All right, love it. All right, we're coming close to the end. Hopefully you're able to fast forward through this and just look at the problems that you need. So number 41. So we're not going to we're not graphing this. We're finding the limit. So we're going to take the limit as x approaches 1 from the right of x squared plus x plus 1 over x cubed minus 1. Okay, so we can factor the bottom, and let's see if something happens. The top won't factor. But this is a is equal to x and b is equal to 1. So it's x minus 1 times a squared, x squared, plus a times b, so plus x, plus b squared, which is 1. So that will cancel. Okay, so you end up with the limit as x approaches 1 from the right of 1 over x minus 1. So that's 1 over a small positive, right? A little bit bigger than 1. So that would be positive infinity. All right, lovely. 43. We're taking the limit as x approaches 5 from the left of 1 over x squared minus 25. Okay, so on top there's nothing that'll cancel out. It's just, so we've got a non-zero over 0 situation here. From the left, that's like 4.99 squared. It's going to be a little less than 25, so that's 1 over a small negative. So that would be negative infinity. So again, if you're confused when to do the small negative, small positive thing, it's when you have non-zero over 0. You also do it with absolute values. That was in an earlier section. And so number 47, and this is the last one here. So we have a 25-foot ladder is leaning against a house. If the base of the ladder is pulled away from the house at a rate of 2 feet per second, the top will move down at a rate of, and we have this equation here. Find the rate when x is 7, when x is 15, and then find the limit as x approaches 25 from the left. Well, you're just, for A, you're just plugging in 7. So the rate is equal to 2 times 7 over the square root of 625 minus 7 squared. All right, and that's going to end up being 7 over 12 if you reduce it, or whatever the decimal version of that is, in feet per second. And then part B, you're going to plug in 15, so 2 times 15 over the square root of 625 minus 15 squared. And that ends up being 3/2 feet per second. All right, and then the limit part. So go ahead and pause the video if you need to, so I can erase this, and we'll take the limit. Okay, we want to take the limit, so still number 47, part C. Take the limit as x approaches 25 from the left of 2x over the square root of 625 minus x squared. Well, if we plug in, since it's from the left, this is gonna be 50 on top, right? 2 times 25. And on the bottom, a little under 25 squared, take the square of that, so it'd be 50 over a small positive. All right, so that's going to be positive infinity. Another thing, the positive infinity, negative infinity, those come about when you're doing from the left and from the right also, you know, and you have a non-zero over 0 form. So if it's from the left, from the right, you got non-zero over 0 form, that's when you will get, that's when you use the small positive, small negative situation. Okay, that does it for this video. This video is very long for Hwk Solutions. So I will talk to you next time.